I'm gonna eat some blueberries. I hope it's not too noisy. All right. I gotta remember that I can cut out the beginning of the video when I post it. So while I'm waiting for people, I'm gonna draw a little diagram. I don't know why I'm talking if I'm gonna cut this out, or maybe I will forget to cut it out. We'll see. So we don't want a background. Yeah, an orange color is fine. That looks good. Now, is there a polygon? Diamond, circle? No, apparently not. Click to start multiple points. Drag for a single line. Oh, that's kind of cool. Nice. Just gonna wait a couple more minutes. We'll start very soon. Alright, I'm just gonna start. I'm too impatient to wait longer. So, welcome to those of you who are here, and welcome to any future viewers who watch this on YouTube. Today we're going to be doing triangle rasterization. Now, if you were in a previous stream, you'll remember that last time we created the beginnings of a software renderer, and we were able to draw rectangles onto the screen. That's all well and good. Rectangles are pretty easy. Triangles are a little bit harder. Now, I'm going to say I've never done this before, and a friend of mine, his name is Nick, gave me a brief explanation. Well, I think it was a pretty good explanation of how he does it, or how he's done it in the past, and I'm going to try to reproduce that here, although, as I said, I haven't done it, so I'm just kind of going off of what he said. And we'll figure it out from there. So, let's get into it. So we can imagine that this large box here is our canvas, our screen, our drawing area. And it's got a bunch of pixels, so I'm going to make the pixels really big. So let's just say the pixels are something like that large. I'm going to use a different line style. Hang on a second. I'll make it less sloppy. There we go. So something like this. And just bear with me for a second while I create a grid here. The reason I'm making them so big is just for demonstration purposes. It'll make everything a bit easier, hopefully, to explain. And yeah, that'll do. The last one is a little bit big. Whoops. Okay. So something like this. And can I grab all of these and rotate them? Can we select? No, apparently not. If I paste these, can I rotate them? What does this do? Yes. Very good. And I want to just try. Oh no. I want to decrease the height without decreasing the width. I can't do that. Well, they're just going to go off the bottom down there, and that's fine. I don't think it'll be a problem. Okay, so we can just pretend that our screen ends, and we can just say it ends here, and don't worry about the rest of those lines there. All right. God, that's... Sorry if you have OCD, but oh well. Okay. So here are our pixels, and on the left side here is a different box. I'm going to make it green so that it stands out a little bit. So these are our pixels, and as I understand, basically what we're going to do is we're going to go around from each vertex of the triangle, starting from 0 to 1, then 1 to 2, then 2 to 0, and we're going to do some operations. So we're going to figure out basically the extents of the pixels of the triangle. So I'm going to actually change the shape a little bit here to make it a bit more obvious, I guess, what the triangle would look like, because these are huge pixels. But let's say something like that. Okay, with 0, 1, and 2. Give me that 2, please. There we go. Ah, what just happened? That's fine. Okay, now I'm going to bring this to the front, actually. Bring to the front. There we go. So, what we need to do is, I should explain what this box is. This green box is going to be a table or an array, some kind of data structure. And we're going to store the minimum and maximum pixel value on the x-axis. So what we're going to do is we're going to basically figure out the line that covers this part of the triangle along one row of pixels. So in this case, we can see this is pixel 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'd say index 11. So in here, it would probably be 11, 11, because this looks like it's going to be just one pixel, and this pixel is probably going to be empty, right? I don't know exactly how it's going to turn out, but we'll see. So something like this. This will be 11, 11, and then this one would be 10, and the end would be, let's say, 13. I would say that one probably takes up the entire 3 pixels there. Something like this, etc., etc., etc. And then we get down to, down here, and then this one might be, what is this, 11, maybe 12, 13, 14, 12 to 14, something like that, down here. Okay. And so how do we calculate these rows of pixels? I'm trying to go off memory. I'm a little bit underslept, but I think what we do is we calculate the distance between these vectors, and then we need to do some math to figure out how far down we go. No, how far to the right we go when we go down, or how far down we go when we go to the right. Yeah, I think how far down we go when we go to the right. So, yeah, that's going to be a bit confusing, but let's see. Let me think about it. Okay, I feel like I need to do something before I can figure this out, but we should be able to figure it out on paper. So let's use a really simple example. We'll grab, I'm actually going to move this down, and we're going to make this a, what are these called again? Triangle with the flat base at the bottom. So we'll make it this kind of triangle to make it easy. In fact, we might even make it a right angle triangle. Okay, and we're going to calculate this one first. So what we're going to do is get this position here, which is 0, 1, 2, 3, 4, 5, 6, 7. So we're going to 7, and we're going across to 14, I think. Yep, 14. So we're going 7 to 14, which means this is a distance of 7, and the up and down is going to be 0. So that's already too easy to calculate, I guess. So we never go up or down on this row. Okay. What about this one here? So it's also 7 to 14 because it's the same distance along the x-axis, right? So 0 to 1, I'll put, so 0 to 1 is 7 to 14. But on the y-axis, it's going to be 0, 1, 2, 3, 4. Four, 5, 6, 7, 8, 9. 4 to 9. Okay. So that means we need to figure out how far, each time we step across one pixel, how far down do we go? If that makes sense. When we're going down this slope here. So if we get the distance, or the difference between these two, let's say d equals v1 minus v0, that's going to give us the difference as a vector. Then we want to, I think we need to divide the y by the x. Doing Bresenham's algorithm? Bresenham's? I don't know. I got an explanation from a friend. I think that's what he said it was. I've never done this before, so I'm just trying to figure it out from the explanation that he gave me. So I thought we would do that. So it seems kind of fun. Let's have a look. Bresenham's algorithm. Bresenham's line algorithm is a line drawing algorithm. So the top left is 0, 0, such that pixel coordinates, hang on, let me just show you what I'm looking at. I'm looking at Wikipedia here. Here we go. So, following conventions will be utilized. No, I already donated to you guys a long time ago. What? Are you kidding me? Wow. You can't get rid of this anymore, huh? Alright, whatever. Top left is 0, 0, such that pixel coordinates increase the right and down directions, e.g. that the 7, 4 is directly above the pixel at 7, 5. The pixel centers have integer coordinates. The endpoints of the line are the pixels x0, y0, x1, y1. Okay. The algorithm will be initially presented only for the octant in which the segment goes down and to the right. And its horizontal projection x minus 1, x minus 0 is longer than the vertical projection y minus 1, y minus 0. Right. Okay. That's a bit confusing to me. Let's see. The line has a positive slope less than 1. In this octant, for each column x becomes x0 and x1, there is exactly one row y computed by the algorithm. Chooses the integer y corresponding to the pixel center. Right, yeah, so, yeah, this is what I thought. So the fractional y could be this, sorry, the y could be on the same x. Yeah, on successive columns, y can remain the same or increase by 1. Yeah, okay, that's what I was thinking. But that means, so the problem with this is we can draw this line, right? But then how do we draw a line going this way? Or down to the left or up to the left? I think it should be the same code. I don't know, I guess I'll have to try. Okay, since we know the column x, the pixels row y, is given by rounding this quantity to the nearest integer, yeah. So the slope, so, okay, yeah, x1 minus y0, sorry, y1 minus y0. So you invert the points, says missing in the chat. Invert the points pretty much. Right, okay. Yeah. I know this algorithm. Hey there, Arctic Flare, thank you. Keeps an error bound at each stage. Yada, 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 yada. All right. I'm going to start by trying to draw a line like this. So I will put some coordinates on the screen first. Let's have a look. Okay, so we've got our drawing code here. Let's see if we can draw things. Pixels, there we go. We need that code. So actually last time there was a problem, and there is still a problem. When we exit the program, it's still running. So something is not being handled correctly in the exit code. And I've tried releasing a bunch of things, but I don't think it's this. The error goes away if I don't use DirectX 11. So it's something to do with DirectX, but I don't know what. And I'll figure that out, as I said, off stream, because it's really not that interesting. So let's say we've got a triangle, and we'll just make a triangle of 3 points, I guess. Do I check for WM quit? No, I use, actually I need to add breaks here. I didn't do that. I'm not used to having to break because I use Odin all the time. So that's actually a bug. WM quit is not handled here. Do I need to handle that explicitly? What would I post? Quit message? Would it be the same as this? No, that didn't work. So basically I'm closing it like this. When I press escape, I post a quit message, but maybe I should instead do destroy window. And set running to false. And then that would call this. I guess I don't need to do that then. Not sure. I need to look into it again. Anyway, that's not what we're doing right now. WM close. I'll have to handle WM close. Alright, hang on a second. Okay, sent us a signal that a window application should terminate. A window receives this message through its window proc function. Right. So, okay. So they just have destroy window directly in here. And break. Yeah, no dice with that. If I press the X, still running down here. That's what I'm talking about. It's alright. I don't want to debug this right now. Let's go back to the triangles. So triangles, we need 3 positions that our triangle is going to be in. I'm going to use floating point numbers because eventually we're going to use 3D. So let's say triangle is going to be 3 floating point numbers, and we're just going to put, let's see, no, it's not going to be 3 floating point numbers. It's going to be 3 vec2s. And they are going to be, so in X position, let's say 100. I should use the floating point. I know it's going to convert anyway, but 100, 100. So that would be the top left, and then we'll go 200, 200, and 100, 200. So we've got a right triangle here that's got a slope that's going, sorry, down to the left. I mean, down to the right. I'm getting confused now. I'm trying to do it backwards for the camera. And let's just draw pixels at those positions. So we'll do triangle dot x. Oh, there's no. Oh yeah, it's an array. Triangle 0 dot x. Is that right? No, just yeah. Hang on a second. Which one is position? The first one? First one. So I'm gonna have to change this to U32, or cast it rather. That's not how you cast in this language. Okay, and we're gonna say that these squares are gonna be, let's do 4 by 4 pixels, and we'll subtract 2 from the positions so that we get the center being in the right point, and we'll just do that 3 times. Why did I do that? Yeah. 0, 1, 2. And we should get 3 dots on the screen. There we go. So here's our triangle at the top here. Now, we need to figure out this slope here and draw it. So I'm going to try to do that first. I shouldn't have waited so long to start streaming. It was like maybe an hour and a half ago that he explained this to me, but I already kind of forgot. Yeah, so we'll start with, I guess I'll just do it right in this loop here, just to figure it out. So we got vec2, which is going to be diff, and that's going to be I don't have a subtract. Okay, actually I'm going to do dx dy, I guess. No, actually I'm not going to do that. Vec2 sub triangle 0, triangle 1. I don't have this function yet. So I'm going to make math.c, I guess. And this would be vec2 sub and vec2a, vec2b, and it's going to return vec2. I'm not going to worry about SIMD and stuff right now. What is it called? There's a shared one, right? Did I make a shared common.h? There it is. Common.h. Okay, great. So we're just going to return vec2 x equals b dot, wait, we subtract a from b, right? Or do we subtract b from a? Sub, I can't remember which way this usually goes. I'm having a brain fart. Yeah, it's a minus b. Yeah, a minus b. A minus b. Yeah. Of course it is. Why would it be the other way? Yeah. Dot y is a dot y minus b dot y. Okay, there we go. Easy. Great. Okay. So we have our, what? Sorry, wrong function. There we go. Vec2 sub, we need to include math here. Okay, so we should have our difference between 0 and 1, but probably want to subtract 1 from 0. Because we know the direction that we're going in, which is going to be down and to the right. Okay, and then we need to calculate, I think it's called dy, and we divide, what do we divide here? Yeah, I'm trying to remember high school. It's really hard to remember. That was a long time ago. I'll look at the page. Is it this? y1 minus y. No, that doesn't seem right to me. Function of x equals mx plus b. Oh, it is this. Okay, Hexa is saying it's this y2 minus y1 divided by x2 minus x1. Okay. Right, so that would be, well, I didn't need to do this then, the diff. So y2 would be triangle 1 dot y, triangle 0 dot y, minus, no, divided by, triangle 0 dot, no, 1 dot x, minus triangle 0 dot x. This is going to be a painful stream. Sorry, guys. Thank you for your help. Okay, so we've got dy, and then we can, I think we can do something like 4. Right. Okay, so the diff is this, which is going to give us how many iterations we're going to do. So we're going to iterate I equals 0, I is less than. I guess I'll just past diff dot x. That's going to be the length of the line on the x-axis. I don't know if I should be putting this in the loop here, but anyway, let's see what happens if we do this, and then we draw. I'm just going to do something really simple. Draw a rectangle at diff.x plus I diff.y. No, not diff.x. Triangle 0.x plus I. And this is just going to be triangle 1.y, no, 0.y. The width is going to be 1 and the height's going to be 1. Okay, let's see if that draws a line across from the top. Yeah, okay, that's what I expected. All right, good. Great. It's still running. Okay, good. Okay, that's great. I don't really like changing. I'm going to actually... What does this dy evaluate to? Let's have a look. I'm going to break here. Okay, here we go. This debugger is called the RAD debugger. It's made by a couple of guys, mostly Ryan at RAD Game Tools. Okay, so dy here is 1. Interesting. That's because we have a right triangle. So then we're always stepping 1 down or 1 across as we go down. Okay, I'm going to change the coordinates and see what happens here. So if we change the coordinates slightly to a little bit further away, so we have a more gradual slope on, no, not this one, on this one. Let's see what happens. Now we get a dy of 0.714, which means we go down 0.714 for every x pixel that we go across. Okay, this is making sense now. Yeah, see, that's why you got to look at the data. If you're not that strong in mathematics anyway, then you can look at the data, change some things and see what happens, and then it just makes sense. All right, so that's cool. That means we can actually set this position to be plus, and I'm just going to put y offset here, which is going to be f32. Y offset is dy, or do I want it to be 0? And then y offset plus equals dy. And is it going to draw a line for us? Oops. I got to get rid of that break first. Hey, look at that. Drawing a line. Okay, that's great. That's great. Good stuff. So, I'm pretty sure you could check to make sure you're not double drawing pixels or something, but we're not going to worry about that right now. Okay, now that I understand this part again, or more clearly, now I can explain what this is. Okay, so basically, as you just saw, we're starting at this pixel and we're iterating through a loop, which is going to be the horizontal length of this line. So 1, 2, 3, 4, 5, 6, 7, 8 pixels. And each time, at the end, we're going to move down and to the right by the dy value, which is going to be... Yeah, interesting. I thought you could calculate that a different way. So that would be... Anyway, this is the dy value here. And we move down by that much to get this line. And what that gives us, in this case of this line, is the maximum x value of this row of pixels. So that gives us, what is this going to be? 11. Why is that 13? Oh, because I had it different before. Okay, so this is 0, 1, 2, 3, 4, 5, 6. Oh, I already had the number here. So this is going to be, we'll get rid of the minimum values because we don't know that yet. 7. Hey, what the hell? 7. Okay, and then 8, I guess. We're going down. I mean, it might be 8 or it might be 7 again because the slope was gradual, right? Actually, let's change this one to a right triangle. So we'll do, is that a right triangle there? 1, 2, 3, 4, 5, 6, 7. Yeah, I think so. 1, 2, 3, 4, 5, 6. Oh, it was a right triangle, apparently. Okay. What just happened? All right, so it's going to be 7, 8, 9, 10, 11, 12, 7, 8, 9, 10, 11, 12. No, I'm being stupid. This is a right triangle. There we go. 12. Yeah, you guys get the point, right? So we're going down by that y value, and then we can store the maximum pixel of this slope, which is what we need. And then we need to calculate the minimum pixel of this slope here. So let's just say, so now we need to figure out how to get this line as if it's a line like this, if that makes sense. Because we need to run the same code on the other edges here. And then we can basically, let's just say we have a triangle like this, so it's a little bit easier to visualize. If you do the same calculation on this line here, however we end up doing that, we're going to end up with a minimum value and a maximum value. Or we're going to end up with two values, and then we can just compare them, say which one is bigger, which one is smaller, and we'll end up with something where the left side here is going to be, actually I'll put it back here, the left side is going to be 7, 7, 7, 7, 7, 7, like this. Right, so it's just going to be 7s all the way down because this is a straight line. And then the max value is going to be stepping up. And that's going to tell us how to draw our rows of pixels. So the next step is we need to figure out how to do the same calculation on a line that's not going from the top left to the bottom right. So Missing said in the chat a while ago, you invert the points. So let's think about that. If this is going from the top to the bottom, we just need to figure out which one is in the top left and which one is in the bottom right, I guess. But what about in this case? If the triangle is this shape, there is no top left and there is no bottom right. Could we run the same algorithm on this? Let's see. Need to do a little bit more experimentation. So x-axis, going to move it over to 150. Now we get a triangle kind of like this. Okay. Let's see what happens in the next. So I didn't use this at all, this difference. Did I? Oh no, I did. I used it to calculate the amount of pixels, right? So let's see, we're going to do diff again. So in this case, we've got a triangle that goes this way, a line that goes this way. So we want to subtract, I guess the order would be, if we subtract 1 from 0, we should subtract 0 from 2, I guess. So 1 from 0, 0 from 2. And that's going to give us a new diff value, which we should check. 50, negative 100. So 50 to the right, negative 100 up, that's correct, yeah. And then if we get the dy again, what is that going to be? I'll just copy this. So we're doing 2 and 0, or 0 and 2 rather. So this is 1 and 0. So we're going to change the 1 for 0 and the 0 for 2. Okay. All right, what does that give us? Negative 2, which means we're going to go up by 2 pixels as we go across by 1 pixel. Okay, that makes sense. All right, so that means, okay, I think I remember a missing piece now. We need to get the signed direction. So if you don't know what I'm talking about, usually in our renderer and a lot of renderers, the pixels go from top left to the right and then to the bottom like this. So this is 0, 0 up here. And so you can imagine if we're moving to the right, the x-axis, on the x-axis, so moving to the right, then we could have a sign of +1. So the direction is +1 on the x-axis. And then if we're moving to the left, it would be a -1. What the hell? -1. Okay, so that's left and right. Yeah. And I wonder, it doesn't matter. So, and the same for down and up. So down would be +1 and up would be -1. And the reason that that's important is because we got this slope here where we're moving to the right, but we're moving up instead of down. So before we were adding our y offset here, or our dy. So we need to make sure that we're adding a negative number, which we will be because that was -2, right? And then the other case that it's important for is if this point was over here, for example, then we wouldn't be going from, I think in this case we would be starting from here and then we would have to add -x. So we'd have to get the sign of the x value and go up this way, if that makes sense. So yeah, okay, we'll sort this triangle out first. Let's see. So we've got something like this. We've got our diff again, so we're just going to use this code again. I'll clean this up in a sec, but we're just making sure we can draw some slopes here. This is going to be triangle 2. Okay, I think that's going to work for our purposes. Did that compile? Yes. All right, look at that. Great. Cool. Okay, got 2 lines working. Now, hopefully the third one is going to be just as easy as that one. Let's have a look. So we're doing 1 to 2. So we're going clockwise in this code, which I don't really mind which way we go. That might be important later if we want to not draw triangles that are going the other way, for example, when we do 3D stuff. So we're going to do the same thing, but it's going to be 2 and 1, or 1 and 2 instead of 2 and 0. So 2 and 0 turns to 1 and 2. I think, yeah. Wait a second. It's not 1 and 0, it's 1 and 2. 1 and 2, 2 and 1, 2 and 1. God, I got myself confused already. Okay. Okay, if it's 1 and 0, then it's going to be 2 and 1. I should have just made a function for this to make it easier, but that's fine. And this is going to be 1. Okay, is that correct? Maybe. I don't know if this is going to work because we didn't add the sign in there, so we might get some kind of bug because we're trying to draw outside of the window or something, I guess. What's the X position? Yeah, that's not good. Okay, 2 and 1. Right, that looks correct. Okay, but I think because of the sign on the X. So it needs to be plus. Okay, what's the sign? Do we have a sign function? I don't think we do. Well, we definitely don't, because I only just made the math library. So sign would be, I'll make it, can I call it sign F, or is it going to conflict with something in the compiler? Let's see. I'm just going to return 0 and see if it complains. Okay, that's fine. So this is going to be if x is greater than 0, return 1. Else, no. If x is less than 0, return -1, return 0. I think you can, yeah, you can have a 0 sign when it's 0. So the sign is going to be the difference, right? I'm going to just break down here, look at the numbers, get my bearings. I can't look at the numbers because I tried to draw something here. Okay, here we go. So we've got dy is 0. That's weird. Do we make a right triangle again? I don't think we did. No. Oh yeah, this is the third line, which is going straight across. Right. Okay, so this is this line. So dy is going to be 0. Yeah, that makes sense. Cool. That's fine. The diff is -140. So basically, we want to sign the x difference. Yeah. All right. So I'm just going to say sine x, I guess, equals sine f. That's kind of confusing. Let's call it, yeah, whatever, that's fine. Diff.x. Okay, and now when we add 1, or I, it's actually going to be times sine x, except now we're multiplying unsigned 32-bit integers with floating point numbers, and I guess we were already adding floating point numbers and unsigned 32-bit integers. I don't like that. I don't like that. I'm gonna just leave it for now and see what happens. Oh yeah. Okay, did we draw outside again? I think we did. Because x is a really large number and y is 200. All right. Why is x a really large number? Something to do with this. Okay, I'm going to put a breakpoint here. let's have a look at these. That's -1, correct? That's -140. That's okay, 150. All right. So yeah, I want to look at this. Oh, show me in here. All right. So X is 240. Is that right? So we've gone to the right hand side first. Okay, yada yada yada. Okay. Now, oops. I'm pressing F11. No, I'm pressing F10 by accident. All right, so there we go. Yeah, let me have a look here. What are we up to? We're up to 236. Okay, so we are going from right to left this way, which is kind of what we expected, I guess. Because we are, yeah, this way, this way, this way. But for some reason, it must be our loop. Let's have a look. Yeah, let me get out of here, please. So what's this? Diffx. Oh, yeah. That's the problem. We iterate I until -140. Yeah, that's not going to work, eh? This needs to be absolute number. So if I multiply this by -1, it's going to give me a positive number, right? And if I multiply a positive number by 1, it'll give me a positive number. So is this going to work if I do this? No. Apparently multiplying a negative number by -1 gives you a negative number. I thought it was positive. Oh, yeah, right. I didn't see the result of this. Yeah, stupid me. diff.x times sine x is 140. Okay, so this should work now, I think. Oh, there we go. Would you look at that? We're drawing triangles. Well, we're drawing the lines of the triangles. Hello. Stop, please. Cool. Okay. Now that we've got that, we can fill in that table I was talking about. So we've got to create a table of pixels, I guess. Potential pixels. Now, how do we want to do this? So, our current renderer is 1920 by 1080 pixels on the screen, so it's pretty big. And if we make a table that is the whole screen, it'll be, I guess, 1080 times 2 numbers. So, pretty big, kind of wasteful, just for one triangle. But I guess we can reuse it for every triangle, so maybe it's not that big of a deal. So we'll just make that right now. So we'll call it vec2. Actually, it's not really a vec2. So I'm going to make a triangle extents. Okay, I'm going to say it's an array of, I can't really make it 1080 on the stack, can I? So I'm going to make it. Triangle extents is pointer to unsigned 32-bit integer array. So it's going to be an array of 2, or a multi-dimensional array, I guess. Triangle extents, maybe I should make a type for it, like a vec2i or something. Yeah, I'll do that. Because I'll use this for other things later anyway. Not F32, U32, data. Alright, so we've got 32-bit vec2, unsigned. No, wait, I don't want unsigned. I want signed Yeah, signed. That's fine. Okay, there we go. So I'm going to say triangle extents is going to be vec2i array. So it's going to be a pointer. We're going to make, how many are we going to make? We're going to make 1080 or window height, actually. I should probably call this render height instead of window height, because it's a little bit confusing, but anyway, that's fine. Where were we? So window height, so 1080 of them, and we're going to use the not context permanent allocator. Very good. Okay, got triangle extents. So this is our table we're going to store data in. All right. We're going to store the left and the right position of each row of pixels for this triangle. Okay. Let's see. Yada yada yada. Okay, so in this case, let's see if we can just do it for this first slope first. So I'm going to just comment out these two here. Just focus on the first slope. And what we want is basically we want to iterate through each x position and then say if the value is less than the minimum value, then we store that. If the value is greater than the maximum value, then we store that. So I guess we would say something like triangle extents, and this would be the row. So we're using floating point here, but we need to convert this to an integer. And it needs to be rounded. Which way? Up, down, or rounded? I guess we'll just truncate it for now. And we'll probably experiment with different rounding in a little bit. So we want to cast to U32 triangle 0.y plus y offset. That should truncate it, right? So that would be row. And then this would be row 0 equals min. Wait, do I even have min? I don't have a standard library, so I might have to make this. So we'll say min f, but actually we should store pixel values, not floating point numbers. So I'll just put, I'll just use min and see if we can make that function in a second. Or actually I'll just avoid that for right now, and I'll just say if triangle extents row is less than, no, if the x position, which is this, the column is less than this, then we're going to store 0 or x. No, I'm going to make that 0 because otherwise it'll get confusing, because it's not actually an x position, it's a left offset or left position. Triangle extents row 0 is equal to column. Okay. Else if column is greater than, or not else if actually. Oh no, yeah, it would be else if. Okay, whatever, I'll just do it like this. Triangle extents row 1 there we go. So we're basically storing the value if it is larger than the value that's already in there, by default, all of the values will be zeroed because of the allocator. And there's some kind of error. Subscript value is not an array, pointer, or vector. Oh yeah. I have to use .data to use the array version. Okay. Now, I want to have a look at that data. So let's see what happens to triangle extents. Let's see, triangle extents. Yeah, 000, that's fine. I'm just going to get the address and go here. Okay, there's a lot of no data. And then, what is this number? 150? Does that sound right? I think that sounds right. So we start at 150 and we go down to 240 gradually. Or actually, yeah, not that gradually, but 150, and then this is 152, 154. I'm skipping one pixel over here, so 156, 158, 159. Yeah, okay, so we're not going down at a 45-degree angle because it's not a right triangle anymore. So this is basically what we would expect. And then at the bottom here, there should be 239. Okay. Right. So this gives us the maximum extent. What about this? Is this the minimum? This should be 1, 2, 3, 4. Wait, wait a second. Yeah, I'm confused. These are supposed to be 32 bits, right? 1, 2, 3, 4. That's 5. Okay, 151, 153, and then down here, 182, 238. This one is 0. I think there's a problem. Let me look at the code again. I forgot what I did already. Okay, I'm going to look at it in a different way. So we're going to say triangle extents is an array of 1080. I think it knows the type already. Here we go. 206, 207, 208, 208. So it's 0 to 09, 0 to 10, 0 to 11, 0 to 12. Right, yeah, that's the problem. Okay, so column is never going to be less than because this is 0, which means I guess we could do one of two things. We could set the values of our triangle extents to be the maximum value of the screen, so something like 1080, so it would always be 1 pixel larger, and then this would work, right? I think that would be fine. Or we could say if this is 0, then we want to set it, except I can see that might be a problem in some case. Let me think about it. So if it's 0, then it'll never be less than the column. Okay, I'm going to do it the first way. So basically what I'm going to do is something, I'm just going to do it a dumb way first. I is less than window height. I plus equals 1. And I'm just going to say triangle extents I dot x, that's the left side, equals window width. Okay. So now we should get, yeah, like this. 150, 150, 157, 157. Wait a second. That's also incorrect. These shouldn't be the same. What am I doing wrong here? So for each iteration, we're going to check the row that we're currently on, which is this. That's fine. Well, that might be fine. It seems to be working at the moment. And then we're going to check if the value in that row is greater than the current column. Oh, yeah, this is wrong. Isn't it? No, it's the same as doing it this way. Yeah. I fear I'm probably doing something very obvious. Alright, I don't usually do this, but I'm really busting to go to the toilet, so I'm going to be back in a second. Okay. Sorry about that. Okay, I've got about an hour left to figure this out. And then I've got to pick up my daughter. So, I'm sure it's not going to take that long. We're almost there. all we need to do is figure out why we're not putting the correct data into the row, into the minimum section. So if we look at the data again, okay, we're filling out the maximum correctly. So as we're going down, we're getting further to the right. That's what we want. But we should be getting, oh, I know why. It's because we're not doing all three slopes yet. So we need to do this for all three slopes. Duh. Okay. Yes, that was very silly. So I'm going to turn this into a function now. I'm going to do something like, I don't know exactly what I'm going to do. Calculate triangle stuff. Where am I going to put this? Guess I've got a software renderer file. I'll just put it in here. Okay, we're going to call it, I don't know. I'm just going to give it a temporary name. Calculate triangle extents. Actually, that's probably going to be the final name. And we'll just put this in here. Pass in a triangle, which would be an array of vec2s. And what else do we need in here? We need the extents. Usually I would prefer to pass in an allocator and then allocate and then return the pointer. But for now, we're just going to pass this in. Okay, we need to include our, actually in common, I'm just going to include math.c because we're going to use that like everywhere. What's the problem? Main file cannot be included recursively when building a preamble. Okay. I don't know if that's going to stop us from compiling. Nope. It's probably just Clang having a fit. Doesn't like how I'm doing things. Clang D. So, cool. We can pass in a triangle. We don't want to pass in a triangle. Oh, we do want to pass in a triangle. Yeah, and then we just want to do this 3 times. So maybe actually we should calculate. Yeah. Calculate slope extents, I guess. A, B, no, not pointer. And AB and the triangle extents, I guess. I don't know if I'm particularly happy with this, but it's fine. Actually, we can just do this. Calculate slope extents, triangle 0, triangle 1, and triangle extents. Okay. 0 to 1, 1 to 2, 2 to 0, and then we can use A and B here. So this would be B, no, yes. It doesn't really matter, I guess. Yeah. Okay, is that right? Maybe. Let's see. I thought I calculate triangle extents. Okay, and then we can have a look at that data when we're finished. After we've gone through all three slopes, we should get the minimum and maximum of the rows correctly. That's what I'm hoping. Okay, I didn't compile, I think. Nope. Hang on a second. Alright, there we go. What's the problem? Right. Yeah, this code is wrong. So, okay, what's wrong? Yeah, 150, 100 to 150. Wait, what? Oh, looking at the wrong thing. Where is it? Triangle. I mean, I already know what the triangle is. I don't need to do this. Yeah. So triangle 2. What's the problem? Okay. Yeah. Difference is -140. dy is 0. Okay. So a.x is... Oh. Yeah, we've done that thing again. I thought I fixed this. Maybe I deleted it by accident. So this should be times the sign, which should be this. Now I got another problem. Apparently, what's that? Oh, I added a break. That's not a problem. Great. Let's have a look. Triangle extents. Okay, here we go. Yeah. Okay, here we go. 150, 150. Okay, is that right? Yes, we're right at the top. 151, 151. Well, that's not correct, but that's fine for now. 149, 152, 153. Hang on a second. What's going on here? I'm going to draw this so you can see how weird it's going to look. Draw. I don't have a draw line function yet, so we're just going to draw rectangles of one height. I equals 0, I is less than, I suppose, window height. Absolutely no optimization yet, and that's fine. So we're going to say the minimum extent is triangle extents I dot. I'll just use 0 here, and this is going to be triangle extents I 0 plus triangle extents. No. So we're going to subtract the extents to get the width, and the height is going to be 1. What's the problem? Am I using the wrong type? It's not an array. Oh yeah, you did that thing again. Keep thinking I'm using 2D arrays, but I'm using structs. Alright, how are we going? Wait. Okay, we got an error. That's good, I guess. Because we're trying to draw... Yeah, show me. What's the position? We're trying to draw... Yeah, okay. Off the screen again. No? Yes. Yeah, we can't draw there. So I'm gonna change this to -1. And we got another error. What is that? Okay. 1919. 1. What's the problem with that? Oh, the width is wrong. That is a big number. And that is coming from here because these are negative numbers. And I is 0. Why are these? What the? Interesting. That's unexpected. I'm gonna remove this code for a second. Okay, that's what I was expecting. Something like this. Okay, yeah. But when I add this code, okay, something really weird is going on here. Maybe because I'm doing this every frame, that shouldn't make a difference. Maybe it does make a difference. I will just do it once up here because we don't need to do it every frame. And we'll see. Yeah. That's fine. That's fine. That's fine. All of these are okay. What's the problem? Software renderer buffer is a null pointer. How did that happen? What? Am I doing some stack overriding here? Might be. So not with this, but maybe with this. Yeah. So triangle is 3 vectors. That's all good. Triangle extends row. So triangle extents is, how big is the buffer? Where is it? Here. So I'm making 1080 vec2 eyes. That's correct. Then we're only putting rows in, but maybe the row is going too high. Let's see. Less than 1080. If I put this in here, are we going to get an error? No. Wait, did I? No error. But software renderer is... What the... How is that possible? Hello, experimentators. Today we have been implementing a little bit of rasterization code. However, we're getting a little bit stuck on part of it, unfortunately. So we're basically rendering, well, we're trying to render a triangle, which is this shape here. So we rendered the slopes correctly. And now we're filling in a data structure which is going to give us the extents of the rows of each pixel, but I think I'm clobbering some data somewhere. So let's see. I'm going to remove this even though it invalidates the code. And let's have a look at this. Yeah. So somehow, okay, I know what I need to do. I need to when does this thing get assigned? Software renderer, buffer, draw begin. Okay, so that's here. So at this point, can't even get to that point, apparently. That doesn't make sense. Huh. Draw, what? Oh, did I? I'm stupid. I left a draw rectangle in here. That's the problem. I'm trying to draw a rectangle outside of the draw loop. Yeah, we can't do that. Alright. Now, what does it look like? Okay, we still got a bug, but it's a different bug, I think. Where is it? Where's draw rectangle? Show me. Alright, so this is a buffer, that's good. The bug is the width is calculated incorrectly from here, because this data is all wrong. So let's put a break here and step through, calculate triangle extents. So we go in here and let me get to, oops, damn it. Now we're in the slope function. Hello. Okay. So where are we? Here. Sine is 1. The difference is this. I is 0. Hang on a second. I'm going to do something a little bit different. There's too many things to step through. So I'm going to see what does this look like after the first slope. Okay, the first slope looks good, I think. We got the, this would be the one on the right hand side, so it would be this one. So we got the values kind of going down, which is what we wanted. I mean up, rather. Okay, let's have a look at the next one. So the next one is the bottom slope. So we kind of want to see, what do we want to see there? Like, this is weird. This is not an IDE, this is a debugger called RAD, or the RAD debugger. You can't actually type in here. There's no editing functionality. I wonder if he'll add that one day, maybe. I don't really see, I think that would just add a lot of bloat. Like this is weird, right? So we're going from pixel row 108. So our triangle starts at 100 and it's about 100 pixels tall. And so at 108, it's 158, 158. So that's the slope that's going, sorry, down to the right. So we're looking at this value, which is the maximum value of the column, so 158. And then on pixel 109, it's 0. So I think we got some rounding issues that's going on here. Because we never... I mean, you can't just skip a row. That doesn't make sense in this case. But anyway, should we try to fix that before we look at the other problems? Let's have a look. What's next? All right, so we went through the last one, calculated the slope, and this looks correct. I mean, kind of. This is weird. So, you know, we're at pixel 200. We want it to be 100 is the minimum value. Yeah, that makes sense. Because the triangle is like this. And then 101. Yeah, that makes sense. That makes sense. As we go up the triangle, we go further to the right on the minimum. But then we've got these weird gaps here, which is a bit strange. I don't understand why we're skipping pixels, but we can probably figure that out if we look at this here. Right. Yeah, interesting. Yeah, I think this calculation is wrong. How were we drawing stuff just before? Alright, let's see. So we had this. Let's just draw these again. Gonna have to give these types. What's the problem here? Yeah, this is a vec2. Okay, so this is going to draw two of our slopes. Now, if I get rid of those debug statements, actually I can just skip over them. Oh no, apparently I can't because... Oh, we're still trying to draw. Okay, so we're running, we got the two slopes drawing. Okay, great. So we're basically iterating over the columns and then going up a row, maybe. Yeah, right, okay. So I think that might be where the confusion is coming from. So iterating over the columns, and then we might go up a row. But if we look at this code here, we're iterating over the columns, we might go up a row, but we might also go up two rows. Right? So then we'd end up with a weird situation where all the slopes might skip the same row. Is that what's happening? Could be. Yeah, I think we're missing part of the algorithm here, but that's fine. Alright. So I'm still not entirely sure how the data gets corrupted when I remove these debug breaks here. So if I run this and I put a breakpoint here. Oh look, it looks fine this time. That's strange. Alright. Okay, if that's the case, then we can use this. So basically we want to draw a triangle. I'm not going to wrap it yet. I'm just going to say we're going to start at row is 0 and row is less than, well, maybe we'll just say row is 100, because actually is it, yeah, 100 and to 200. So we're just going to do something quick and dirty here, which is we're going to reach right into triangle. Oh, that's the problem with this. Maybe. No, well, that's a problem. We're going to draw. Just copy this code here. Okay. Except instead of I, it's going to be row. And what happens if we do this? And I need to remove the breakpoint. We get an error because width is this number. How? Because row is 109. Yeah, see, that's one of those bugged out rows. Yeah, we got this weird issue again where the triangle extents is all negative numbers. Is that just a... is that because I'm in this function, so it doesn't know, maybe? But it should show up here on the stack, right? I mean, in the watch window. Okay, I'm gonna look at the data. Hopefully. Yeah, that's weird. It's not supposed to be that number. So what I'm going to say here is if this is not a solution, this is just to check something, equals window -1, or this equals 0, then I'm going to continue. What happens if we do that? Interesting. Right. So we're drawing a line at the top here, which means the Y position is incorrect because it's just set to 1. It should be row. Yeah. Okay. Yeah. So the problem is our data is wrong, and it's causing all kinds of problems. We're pretty close now, though. Pretty close. So we need to figure out why we're skipping rows. Well, I think it's because the slope of the triangle might be too... what's the word? Obtuse. And so as we go across one, we're going up multiple rows. And if we go up multiple rows, we skip one, which means the data doesn't get filled in. So that means we need to iterate by row as well, I guess. I'm confused now. Yeah, we can't just go across on the x-axis, right? So this is a good example here, actually. So if we go across on the x-axis to here, then the y jumps all the way up to this pixel. So we skip this whole row according to this line here. And if we go, if I move the triangle actually over a little bit, something like this, and if we go across on this way on the x-axis, then we might skip this one and go up to here, which would have the same problem, and then we would just have a missing row. So this algorithm doesn't work like this. There's a missing step here. I suppose we could just do something like if something like this. Next row is this plus this, I guess. Oh no, next row would be a dot y plus y offset plus y offset. That's not quite, is it? I guess that is correct. And then we could say if next row minus row is greater than 1, right? Is that correct? Yeah, and then we could just say something like this. We still want to do the min and max though. So basically, I want to do the same code here, but for row plus 1. This is really dodgy. I just want to see if it works. Yeah, it does work. But it only works in this particular circumstance, and I could imagine if we draw a bigger triangle that it's not going to work, because we're going to have more missing rows. So if we make this triangle much taller, I need to actually change this to be, the row is going to be triangle, I guess I'm just going to hard code it here. Experimentators says progress is better than nothing, and I agree. So we're going to move this on the y-axis to maybe like 400, so it's going to be quite tall, and then we'll just change this. And then, yeah, see, that's not great. Not great. So I guess what we need to do, there's got to be some kind of interpolation happening here, right? So we got all these points of reference. What we could do is check the row, and if there's no value in there, we interpolate between the next and the previous, or maybe as we're drawing it, yeah, we could like scan, maybe we could scan forward and then interpolate based on the distance. So there's something missing. We're missing part of the step here, which is fine because we can fix it. We can fix it. All right, so what did we just add? We added this dodgy thing here. So we could make this a loop. So we could say for j is 0, j is less than next row minus row, I think. Row plus j. Would that work? No. I made a logic error here. What is it? Next row minus row might be 1, which means it would do this one time. If this is the last row, then we're going to get an error. So if, yeah, so if, oh God, I'm going to change this. If next row, no, I'm just going to do this. If j is less than, or less than, we don't know how many rows the triangle has, right? Yeah, that's kind of a problem. If j is less than 1080, or window height. Then we do this. This is getting really messy now. Okay, we got an infinite loop. Because next row minus row might not be... might be 0. J is less than 0. Let's see. I'll put a... put a breakpoint here, and we'll see what happens. So I'm just going to put J and then just step until we get some weird value. 1, 2, 3, 4, 5, 6, yada 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 yada. Okay. We're not really going higher than 50. Oh, actually, we are getting larger each time. Okay, 70. But what? Okay, what are the other values? Let's see. Next row is 260 and the row is 180. Well, that doesn't make sense. The Y offset is 80. That's a huge Y offset. And I is 24. And dy is 3.3. Okay, that's fine. So our triangle is what, 500 tall, something like that now? 8.y plus y offset plus y offset. Oh yeah, that's... No, it's supposed to be plus dy, not y offset. Yeah. That's... yeah, that's fine. Whoopsie daisy. I should remove this debug break and see what happens. Still infinite loop. Okay. Uh-huh. 103 minus 100 is 3. Okay. Yeah, the values are staying very small now. That's what I would have expected. So we're not really skipping more than 3 pixels. Up until we get to here. And next row is less than row. Yeah, okay. So that's kind of a problem. And next row less than row, or hang on a second. Damn it. I thought I had the solution in my brain and then I just lost it. Alright, let's keep going. Alright, so we're at the end. Row is 400. Next row is 394. Yeah, okay. So if next row is less than row, right? Or next row less than row. Whoops. I need to remove that break again. No. I am bad at logic apparently. No, greater than, no. And next row is greater than row. Wait, no, this is the wrong. There we go. Okay, but we didn't actually do anything in this loop apparently, because this is never true. I wonder something actually. Let's have a look. We've got some variables in here, like this one, 300 diff. So we've got 300. This is 100. This is 400. Okay. So we can say the max row is going to be a.y, and then if b.y is greater than a.y. That's not how you cast in this language. If b.y is greater than a.y, then max row equals. Okay. J is less than max row. Will that work? No, not J. Not J. I should just... Alright. I need to make a min and a max function. I just haven't done it yet. I really should do that. Oh, thank the gods. Look at that. Beautiful triangle. Alright. Good timing. I gotta go soon. I'm gonna make a min and a max function now for... I guess, should it make it a macro? Min A, B, and we want to say something like A is less than B, A, otherwise B. Is that right? Do I want to put it in parentheses? Maybe? So, yeah, that should work. I'm gonna, yeah, I think that'll work. Can I compile this? No. Of course I can't. Because min is defined in min_windef.h, which means maybe I could have just used it. Let's see. Now Stefan says parentheses around A and B are a good idea, probably, right? Yeah, probably. Yeah, you're probably right about that. I'm just going to see if this is an intrinsic in the compiler. And see what happens here. Oh. I could have just used them. They're included in the compiler. Wow. That's nice, isn't it? Okay, that means we can use them here as well. We can say triangle extents 0 dot dot is 0 equals min triangle extents 0 dot start at 0 or column. And same thing for max, except it would be 1. And then same thing here, but this would be, wait a second, did I put 0 in there? That should be row. Okay, and then the difference here is we're doing row plus j. This is stupid. For every single pixel, we're also iterating over the whole window height just because of this row count. We don't want to do that. What we do want to do is say next row minus row, and then we want to say experimentators says every time I see a programmer well versed in their keybinds, I am so amazed. I appreciate that. I don't really feel well versed though. I just use a really basic subset of hotkeys. Now we want to say if row plus j is less than window height. Is that going to work? Did I just mess it up again? Bah, I did. I feel like I'm going in circles. So next row minus row. Jesus. And next row is greater than row. Is that going to work? Yeah, apparently not. Why? Because if we go, we might be going up the triangle. Is that right? Because we're not guaranteed to start from the top of the triangle depending on the slope, I think. Ugh. So, and next row minus row. What is this value? Let's just print it out. It's a row difference, not print it. We're just going to declare it here. Okay. All right. So we're almost there. Just a little bit of cleanup code. And I'm going to put this value here. 3, that's fine. 4, 3, 4, 3, 4, 3, 4. Hey, Olex, how you doing? 4, 3, 4, 3, 4, 3, 4, 3, 4, 3, 4, 3, 4. So we should get to an absurd value eventually. There it is. What? Right. Yeah. So if row is greater than next row, then we don't want to do this. I really hate this structure of the code right here, but that's okay. Alex says he's good, just another coding hour of work and then off to sleep. Sounds good to me. Where's my breakpoint? Yeah. Back to streaming in the morning with C++. Oh, I didn't know you were doing streaming. That's cool. I'm going to check it out. Yeah, okay, so that's not correct. Yeah, I don't actually use Twitter that much to read. I post on there, but I don't read it that much because I don't think it's good for sanity. What did I just do? Row is greater than next row break. Right, of course it's not going to work on the other way. If row diff is less than 0, no. Man, how retarded am I? I don't want to break. I want to continue anyway, not break. Okay. We just had a working version and I've just totally forgotten what the problem was. So next row is 103. This row is 100. That's fine. Okay. Next row is 210. This row is 206. Okay. Uh, 363 and 359. Okay, I'm going to actually put row and next row here. According to the classical South Park episode, it's pronounced Artard. Oh, really? Alright, so we're at 400. Okay, the next row is 400. That's good. What happens if we press this? Nothing. So this is probably the slope going along the bottom. If we look at A and B, it's going to be 240, 400, and 100, 400. Yeah. Okay, so we'll just wait for these values to change, I guess. What can I get here? I guess the column. There we go, 255. So this is going to go up until, well, 240. 100. What? 340, I guess. So this should be the end, and then that's not the end. 240. 100. Okay. Column is 341. Alright, that's fine. I don't know why it's... Hang on, let me think about this. That's this one, right? So 240. I can't help but think there's a mistake in this. Okay, so as soon as we got to 100, 400, 150, 100, 100, 400, so that's this one. 100, 400, yeah. 150, 100. That's weird. Are our triangles in a weird order? I mean, our vertices. It was just working, right? I wasn't crazy. What did I do? I'm gonna rewind. Yeah, it was working just after I did this. a breakpoint? Let's delete that. No? Yeah. So this code is working. Because we iterate over the entire max row. Oh no, that's fine actually. Yeah, okay. So the problem is what? That seems fine. Oh, J should be less than max row, right? Yeah. Awesome. Great. And this is just to make sure that we don't accidentally draw outside the window, but I don't think we're going to be doing that, because we've already calculated what the maximum row is. So, yeah. Okay, and then we can delete these. Go down here, we can delete these slopes that we're drawing. And also delete these rectangles at the points. Okay, so one more thing I want to do before I go, because I've really got to go in like a couple minutes, and that is I want to add a color argument here so that I can set the color. Where can I set the color though? It would just be these values here. RGBA. And we need to define a color type. So I'm just going to do that here. Type def. I guess it'll just be, I'm just going to use a struct. Maybe I'll use a union. Oh, whatever. I'll change it later if I need to. So it's going to have U8 RGBA. And that's it. And then when we call draw a rectangle in these places, which is only here right now, we can pass in a color. I'm going to pass in, let's make it yellow. Hey, look at that. All right. I'm going to call that a successful stream. We managed to get a triangle rendering on the screen, which is awesome. I think it looks pretty good. And I want to thank you guys for your help and for dropping by. And if you're on YouTube, watching on YouTube later, I want to thank you for watching. And I hope you learned something. And yeah, that's about it. So next, oh, actually I have an announcement, which I'll also make on social media and Discord later, but I'm going to set a stream time, and I know you guys are here now, so you're probably not going to be happy about this, but I'm going to set it to 8 a.m. on Tuesday, Thursday, and Saturday, my time. So what time is that? 8 a.m. AEDT. Is there a world clock or something? Is this, why does this not, world time buddy, does that help? I mean, why would I want to convert it to my own country? Honestly. I'll do the conversion, I'll post it on Twitter. But basically I'm gonna stream at the same time on Tuesday, Thursday, and Saturday every week so that I can get a schedule going. Because if I don't set a time, and this has got nothing to do with you guys, but if I don't set a time, then I'm gonna stay up late, and then I'm gonna be underslept, and then yada, yada, yada. You know how it goes. If you don't set a schedule, then life just kind of happens to you. Or you let it happen to you, I guess. And so I don't want to do that. I want to be a bit more disciplined about it. So 8 a.m. Australian Eastern Daylight Savings Time, Tuesday, Thursday, and Saturday. I might stream on Sundays as well, just for fun, but it'll be every second Sunday, starting on the 15th. So yeah, that's it. And thank you for tuning in, and I'll see you next time.